I'm Anil Kumar sharing with you a test question on inverse functions. You need to state whether the following statements are true or false. Correct the statement if it is false. 4 questions are there for you. You can always pause the video, answer them, and then look into my suggestions. Question number 1. Inverse of function f of x equals to 2x minus 3 is y equals to x plus 3 divided by 2. Well, you can also find inverse by reading backwards. That is reverse operation. So in this case, you are multiplying x by 2 and then taking away 3. Reverse operation is add 3, divide by 2. So that is correct. So this statement is true. Next statement, question number 2. Inverse of function f of x equals to x squared does not exist. Now what do you think about this? Inverse of f of x equals to x squared does not exist. Well, some of you may write inverse as equal to square root of x. However, if you find inverse, you will actually get plus and minus. Now that is not a function. Do you see that? Because there are two values, correct? Now x square, if you graph x square, you'll get a parabola. So that is the graph for x square. It fails horizontal line test. So if I draw a horizontal line, it crosses at 2 points. So this statement, inverse function of f of x equals to x squared does not exist, is true, since it fails horizontal line test. Question number 3. Inverse of f of x equals to x squared plus 2x minus 1 for x greater than equal to minus 1 is y equals to square root of x plus 2 minus 1. Now let's find the inverse of this function. So we know y equals to x squared plus 2x minus 1. First step is to swap, right? X and y. So if you swap, you get x equals to y squared plus 2y minus 1. Now we are completing the squares. So we could write this as x squared equals to y squared plus 2y. We can add and subtract 1 here, right? So we'll do plus 1 and minus 1. Already minus 1 is there. Now this could be written as x equals to y plus 1 whole square. So we have taken care of the first 3 terms, which are y square plus 2y, and we are left with minus 2. Now we can isolate y. So we get x plus 2 equals to y plus 1 whole square. This is just y plus 1. When you square root, you get plus minus x plus 2 equals to y plus 1. And when you take on this side, it becomes, now that is tricky part, right? So we'll get back to this soon. We get x plus 2 minus 1 equal to y. Now it is kind of important to understand that in the parabola, which is right here, we are given x is greater than equal to minus 1. So x is greater than equal to minus 1, and in that case y is greater than equal to minus 2. Since y is greater than equal to minus 2, what we should do here is that we have to, when you take the inverse, it swaps, right? So at this stage, we know x is greater than equal to minus 2 and y is greater than equal to minus 1 for the inverse. Now that is possible only if you take the positive value. Do you see that? So the inverse of the function is as given here, y equals to plus square root x plus 2 minus 1. Do you get the idea, right? So this statement is true. So you need to find the inverse using completing the squares and also restrict the domain and range as given in the question for the function. So inverse of a parabola is possible if you restrict the domain as done in question number 3. So this is very important to understand. Now let's look into question number 4. It says inverse of the function itself, f of x, is x, and f of f inverse x is also x. Now this statement is not always true. So we'll say this is false. Now I'd like you to provide the reason for it or a restriction. As you saw here, we could find the inverse only if domain was restricted. So the condition here is, it is true if and only if the function f of x is 1 to 1. Only then this statement is true. Correct? So that is how you're going to answer it. To give you an example, find sine inverse of, let's say, sine of. Now sine inverse is valid only in plus minus pi by 2. So if I take a value which is 2 pi by 3, if you find the answer, it will not be 2 pi by 3, right? So you will see that this is not equal to 2 pi by 3. So that is an example, counter example, which you can provide. So that becomes a counter example for the given question, right? So with that, I think you get an idea of how to find inverse. I'll provide you with some examples to look into. I should say related examples to help you understand better. I'm Anil Kumar, sharing with you a test question for IB students. Calculator is not allowed. The question is, if inverse of function f of x equals to 1 minus 2x over 3x plus 2 is given by g of x equals to ax plus b over cx plus d, then AD plus BC is what? AD times BC is what? You can always pause the video, answer the question, and then look into my suggestions. Now for such questions, it is better to find the inverse. So what we are given here is y equals to 1 minus 2x over 3x plus 2. So we can interchange. So first step is swap x and y, right? So if you do that, if we get x equals to 1 minus 2y over 3y plus 2. Now let's cross multiply. So we get x times 3y plus 2 equals to 1 minus 2y. So let's open the bracket. 3xy plus 2x equals to 1 minus 2y. We need to isolate y to find the inverse. So let's bring all the y terms together. We have 3xy plus 2y equals to 1 minus 2x. Taking y common, we get 3x plus 2 equals to, let me write this as minus 2x plus 1. So y is equal to minus 2x plus 1 over 3x plus 2. So we know that g of x, which is the inverse function, is basically minus 2x plus 1 over 3x plus 2. So now we can calculate what AD, so A times D, so AD plus BC is equals to 2 times minus 2, that is, minus 2 times 2, plus B times C, cross multiply, C 3 times 1, correct? Minus 4 plus 3, which is minus 1. So option B is the right option. So I'd like you to go through the steps and understand how we really solve this question. This is very important for the new SAT format. Feel free to write your comments and share your views. Sharing with you two practice questions on inverse of functions. So the question number 1 here is, find the value of each of the following. We actually have two questions here, right? So let me just divide this page into two parts. The two questions here are, you need to evaluate what is sine inverse of sine pi by 3. That is first question. The second one is, what is sine inverse of sine 5 pi by 6, right? You can actually pause the video, answer this question, and then look into my suggestions. Now, since we are talking about pi by 3 and pi by 6, let me use a special triangle which relates these values. So if we have a triangle with pi by 3, pi by 6, the sides are 1, 2, square root 3. Now you should also remember that when you're talking about sine inverse, what is the domain you're working with? So let's write it down. So when sine inverse of x we are talking about, in that case x belongs to what value? This is very important to understand to answer such questions, right? So if you look into your coordinate plane, you will realize that sine is one-to-one function only when we are looking into constrained coordinates, right? So basically we take it from minus pi by 2 to plus pi by 2. Now sine pi by 3 is right there in this quadrant, right? Quadrant 1, which is within the domain, correct? So that should work. Sine pi by 3 square root 3 over 2. So we could write sine inverse of sine pi by 3 as equal to sine inverse of sine pi by 3 square root 3 over 2, right? And what value will give us sine square root 3 over 2 is pi by 3. So we do get the answer pi by 3, correct? So here what we have clearly seen is f inverse of f of x is equal to x, right? Reason being that we are within one-to-one function. Is it okay? Only then that is possible. Now this example illustrates right that. Now let's look into the second case where we have sine inverse of sine 5 pi by 6. Now if you look into sine 5 pi by 6, we're talking about the value 5 pi by 6 to be in that quadrant. It is still positive, correct? Now we could say that this is equal to sine inverse of sine, when this is 5 pi by 6, now this remains is pi by 6, right? So it could be written as pi by 6, right? It is positive in that quadrant. Now what is sine pi by 6? Sine pi by 6 is half. So we get sine inverse of half. Now sine inverse is only valid in this domain, correct? From minus pi by 2 to plus pi by 2. And therefore sine inverse, which is a positive value, we get this value as pi by 6. Do you see that? Which is definitely pi by 6 is not equal to 5 pi by 6. Do you see that? So this particular relation, which is f inverse of f of x is equal to x, is not true. The answer is not 5 pi by 6, correct? The answer here is pi by 6. That is the answer. Do you see that? So it is very important to understand that if the part here is not within the one-to-one function domain, in that case we do not get the same value as x, correct? Now here is a practice question for you. So instead of sine, I have taken up cosine. So that is a question for you now. So again, there are two questions. I would like you to pause this video, answer both these questions. First one is, what is cos inverse of cos of minus 2 pi by 3, and the other one is cos inverse of cos pi. Now remember, cos inverse, so cos inverse of x is actually only valid in which domain? So when we talk about the cosine function, we are talking about the function in this domain, right? So we have restricted the value of x within 0 to pi, correct? 0 to pi. Now if you look into this particular equation, then you know here we can say easily that this is equal to pi. The reason is within the interval x 0 to pi, it falls, correct? Cos is 1 to 1 function, right? You will get this answer. You could do it. So we know cos pi is 0. So we get cos inverse. So when you say cos pi, in that case, we know that cos pi is, wait, let's look into this function. So let's do this. So cos is 1 and it's minus 1 for pi, correct? So we could say that cos pi is minus 1, so which is minus 1. And cos inverse of minus 1 will be equal to pi, correct? So we do get same answer. Since we are working in the domain 0 to pi. Now in this case, cos inverse of cos of minus 2 pi by 3. Now minus 2 pi by 3, if you see, is not in the given domain. Minus 2 pi by 3 means that, so it is here, minus 2 pi by 3. That is minus 2 pi by 3. So you will not get minus 2 pi by 3 as your answer. That's what I'm trying to show you here, right? So let's try to solve this. So we get cos inverse of, this is 2 pi by 3. Correct? So the acute angle is pi by 3, correct? So the acute angle is pi by 3. So we could write this as cos of minus 2 pi by 3 as cos of pi by 3. Now this value is negative, correct? Since it is in quadrant 3, it is negative, right? So we'll write this as negative cos pi by 3. In quadrant 3, we know all are positive here. Sine is positive in quadrant 2, tan in 3, and cosine in 4. Now minus 2 pi by 3 lands up in the terminal arm in quadrant 2, so it's a negative value. Now getting back to the special triangle, we'll just make a special triangle to get the value here. 1 to square root 3, angle pi by 3. This is minus half. So we get cos inverse of minus half. Now whenever you do cos inverse, you have to look into the domain 0 to pi. And that minus half, it is minus half in quadrant 2. Correct? It is minus half in quadrant 2. And therefore, the result which you get is 2 pi by 3. Right? Where the acute angle is pi by 3. So the answer again is not minus 2 pi by 3. It is 2 pi by 3, not exactly same as x. Since x is not in the domain 0 to pi, which makes cosine 1 to 1 function, correct? So the answer for part A is 2 pi by 3 and for part B is pi. The whole idea in this exercise is to understand that whenever you're doing inverse functions, you have to check this part, whether it is within the domain or not. If it is within the domain, in that case, You could always write f inverse of f of x equal to x, right, in domain only, otherwise not. So that is what we are emphasizing. I hope the point is absolutely clear. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that would be great. Thanks for watching and all the best.